Welcome everyone for Cloud Computing and Big Data, or Lecture 9 today, Platform as a Service. And as the name suggests, it basically builds on top of the infrastructure as a service that we had the last time. And on top of this, of course, we also have to think about what added value could we bring. Infrastructure was very low level. You have seen VMs, you have seen basically the idea of virtualized resources, but the real higher level services that really bring benefit for an application development were not really there, right? It was basically not as bad as plain metal, but of course also not, let's say, really services for billing, services for, scaling and loading your applications. So these are things we have in the platform as a service. They're like Lego bricks, I will tell you today. But before we come to the material of this lecture, as usual, let's review what we had the last time. So the last time was really, again, thinking about cloud computing in general. So we have discussed the three levels already a little bit. So, there's infrastructure as a service, platform as a service, and software as a service. And basically, you can a little bit hierarchically stack them. Although I have to say, as this picture suggests on the left, it's not really a really hard boundary to this. So you will see some providers will put it in the category of PAAS. Some would put some things into IAAS. So in a way, you see, it depends what you mean in terms of infrastructure, for instance, for whom, right? So in one respect, you would have this clear idea of infrastructure first, platform on top, and really the high-end application as a SaaS. But we have seen last time in MapReduce, this could mean different things, right? In one respect, infrastructure could be just bare metal, right? This is what I have in terms of infrastructure, and I use it as infrastructure. For other users of machine learning, for instance, that have no idea about HPC, no idea about, cloud computing, etc., they just want to do machine learning on MapReduce or big data analytics on MapReduce. For them, MapReduce is an infrastructure. So this is where the interesting part now begins, with this kind of boundary that is not really 100% always given, right? So it depends a bit, where is your infrastructure ending and your platform starting. Hence, you could see MapReduce as a service, as a platform in a way, because it's a platform for MapReduce jobs, it's a platform for many applications. On the other hand, it's just an infrastructure for some of the data analytics people to use it, really given. And that's what we discussed a little bit the last time, if you remember. If, basically have now the choice in the company and people say, we need urgently MapReduce, then you say, wait a second, should we really install it ourselves? Basically, using maybe then virtualization, resources with a MapReduce appliance. So basically put VMs. Then we had this MapReduce hosting, if you remember, that we just have a company that we work with. Let's say you go to Origo here, the software provider, or Advania, and ask them for, can you give us a MapReduce for hosting? Or you go to a, high-end service, MapReduce as a service, basically that you have in the Amazon Web Service or MS Azure and so on, right? So this would be then, of course, a credit card swipe and so on. While maybe with MapReduce hosting, that's a bit the difference. You maybe get a better deal, right? If you are in Iceland, for instance, or if you're in Germany and you talk to a German provider next door, T-Systems, they maybe give you a much better deal than maybe a hyperscaler will do. That's why it's maybe also good to talk about the MapReduce specific hosting. Then we have looked a little bit on infrastructure from two directions. Basically, we have known since the actually course start already, there's EC2, we had the GPUs, the CPUs in it. We understood it's virtualized CPUs, so you share them essentially in this cluster. In lecture 4, we have talked about this. But we have also seen it's not only about computing, right? So of course, infrastructure means you have to store data. Hence, we had also the three types basically that are available in Amazon reviewed, which was basically mostly this bucket store. I highlight this a little bit because S3 in one respect is so-called a de facto standard in the cloud computing community. So many cloud providers will have an S3 interface for you with REST APIs, basically getting the data out of an S3 bucket or into an S3 bucket. So this is object storage. So it's different from, for instance, a file storage that you already know, maybe from your laptops and so on. So there, the storage idea is a little bit different. Then we had also block storage, especially for big data, where you cut it into different blocks. Hence, all of them have the different price scenarios. We have also touched a little bit on Glacier, for instance, as an example, that's for archiving. There's even a deep Glacier. And of course, this deep Glacier costs almost nothing because you have it somewhere on tape archives, take a long time to get it out. And the more you have active storage, really, you can access immediately, the more costly it will become. Another element, if you remember, was the transfer in and out, right? For storage, the idea is, of course, in storage maybe don't cost so much, but getting the storage out, the data transfer, costs you per API call, right? And this is, of course, something not to underestimate. If you have an app and you store your whole situation in the S3, you have lots of REST calls always again to get data for the levels or whatever you do, data for the players, data for this, and you have lots of thousands of this REST API calls, and this costs. This is something also we will discuss and review a little bit today in the lecture of PAAS, because there we start building these apps basically then inside applications like apps. It doesn't have to be that way. You can see Great Scope, for instance, as I mentioned sometimes earlier, is using S3. It's not really an app in this sense. It's a real complete application. But of course, some of the clouds are really optimized these days towards the use of mobile devices. And so this really formalized a lot of stuff we basically have seen before under the umbrella of infrastructure as a service. Again, when you go now to companies, be careful with this term and don't, be more smart than your boss also and say, no, that's not, platform as a service, that's infrastructure as a service. These boundaries are really depending on some observations, really either people have a strong opinion or there's a good point of saying the user has also a view in this. For the users, for instance, of MapReduce, as I told you, it could be seen as a platform of MapReduce or an infrastructure. It depends what basically there's asked for. Generally, the notion, however, and that's what we will explore today, is that the platform as a service is a little bit more oriented towards developers, right? Infrastructure is much more oriented towards administrators, install software on this infrastructure, being administrators for certain applications, for different areas. The PaaS environments is really much more for developers. So this is usually the case. And all of them share a little bit in common that they have so-called Lego bricks, which are very popular, often needed, basically available, that you put together from this cloud to create your real application, right? That you then give to your customers. So we will review this a little bit. What does it mean to have these Lego bricks? We will do some past building block examples, and some of them which are a bit also new, which is, I think, should be a full course here at the university, but we don't have right now someone teaching it, like NoSQL databases. I was alluding to this before. Things like Cassandra, key value stores are very popular these days, and actually are more increasingly used. We will then contrast this a little bit with typical SQL databases. And then, of course, all along we have application examples. Also interesting news for us today, we go to the Google app space, to the Google Cloud space. We have been seeing Amazon, we have seen MS Azure. Now we have the next big, let's say, hyperscaler, Google Cloud, and we'll look a little bit around this. That doesn't mean that Google, for instance, has nothing on the infrastructure. Obviously, they're also strong there. But here they have some different pieces that really highlights the PaaS idea a lot. And then we go to some more application examples. Again, it comes to some of these Lego bricks we will highlight where you really should use rather the cloud than potter off and create your own application, right? So things like using natural language processing. These are, let's say, pre-built models you can just use before you train that your own, and then basically create your own app from scratch, maybe, I don't know, in Java or whatever. There, of course, there's things which you really should consider using the cloud. The same for BigQuery. So obviously there's some interesting database aspects which Google provides that gives you very, let's say, good throughput for big data sets. And here along you see, again, many of these different application examples that are basically there, like Rovio games, for instance, or IKEA and so forth. However, I want to also close then the second part of the lecture today with some disadvantages. The more you adopt these stacks we're talking about, right? The more infrastructure as a service is left behind, going to platform as a service, you basically lock yourself to very specific services in. When you're on the infrastructure level, you basically have a VM, you have a virtualized environment, you can switch that easily from Amazon to MS Azure to somewhere else. Once you start using Google specific services in this PAAS environment, it's getting more harder to switch, right? When you have this Lego bricks, basically more and more getting a vendor lock, as we call, to the users, meaning you cannot port as easy away anymore without redeveloping maybe parts of your interfaces of your app and so forth. So that's all what we plan for today. Let's see how we can connect a little bit this also, of course, with the infrastructure as a service level. Just to remember, again, basically we have now this one level up, right? So we assume underneath we have virtualized resources, things we learned in the last lecture. And here we're thinking now basically this platform as basically a platform for creating something bigger, an application, an app, something which we can build on. And on the same time, we don't want to think about scaling, right? This should be done by the infrastructure. And that's what we have, and that's what we establish. So we can shrink up, shrink down. And these things we assume. And the beauty is now built on this profound infrastructure. I will create my different applications, apps, whatever it is. Now, also, as I said, we looked something new today, the Google Cloud. Here you see, when you look a little bit on the right-hand side, and when you would log yourself in, it has very similar component, a compute engine, here, internet services, cloud storages, different kinds of it. BigQuery we will look in, billing, so Kubernetes engine that we will also look in later lectures, so how you deploy actually clusters and so on. But this means also, of course, many of the services you found in the Google Cloud is also available in Amazon, is also available in MS Azure. But here we pick on some that are really important and interesting, show a little bit the unique selling proposition perhaps of Google Cloud there. But of course, similar service, again, you see in AWS and others. So talking about this, you have another view here. Basically on the lower level, we basically extending the scope. Of course, if you have a platform as a service, inherently, you have still infrastructure as a service. You cannot run the platform in nowhere. Right, so you can see all what is valid for IAAS, so to speak, is also basically included in a PAAS model. When you have a very specific, billing queue for your credit card swipe that you want to do for your game that you develop, of course, underneath it has to run somewhere. It has to run on some compute engine. So hence, this is all in. What we add a little bit to this, what we already know with storages and virtualization, networking. Here, we're thinking about much more development tools, database management, business analytics, statistics. So there are already some components which you then, as I said, as Lego bricks put together to not only launch applications maybe and monitor their status, but also, charge for them, etc. So these are all different development tools that stand alone are kind of boring maybe. So of course, what you need the billing hooks for, but if you combine them with your application logic for your game, let's say Angry Birds as a good example, right? Basically, these combined can then, deliver quickly something for the customers. And the beauty is you basically growing with your customers, right? You can have the infrastructure scalable. So you start small, pay for what you use, as we learned earlier. No basically big costs for, Angry Birds or Rovio games at that time to create very big clusters. Instead, they could start, right? And as you also, I think, was alluding to, it was first a soccer game that failed, right? These things are also there, right? They firstly had a very terrible soccer game and it didn't work. So if they would have bought lots of capital, they maybe would be directly bankrupt. With the cloud, you can quickly collapse this application and start something which is Angry Birds, which suddenly was a major success. As you know, until today, there are movies, there are thousands of these games. But you don't know, as me, right? As a small, medium enterprise, as a startup, you don't know if it will be a hit or not. So basically, this is something where now, of course, the infrastructure scalability, scale with your customers comes in. And usually that's now the PAAS selling argument. The platform components are already scaling with this. So they're optimized, of course, for the usage of the infrastructure. So you don't care if you bill, let's say, 1,000 or 10,000 customers, the infrastructure will follow suit. Because you can imagine if you have to swipe your credit card for your game, and it doesn't work, you will be annoyed, your user will be annoyed, not coming back to your app. Bad ratings, the app will be not long existing. If the application is cool, right? If the application is bad, maybe it's also not existing. But still, you get the feeling that essentially here we have a nice platform, no in-front cost, lots of development hours think about this. If you have your own, application you want to create, you have lots of hours of development costs going in a billing module, in a launch module. So instead, you just take this there, it's ready. Of course, you pay a little bit for it, but you don't have this long development cycle that you have usually basically by creating software for that. And this is the whole idea. Now, interestingly enough, also what I wanted to show you a little bit with this interesting example, of course, here you can now switch. And the aspect of porting is, of course, something which is in cloud computing a very important part. Spotify, I was telling you before, was using S3. And now I'm telling you suddenly they use a Google Cloud. And basically they use both. And in a timely fashion, they sometimes use more this, sometimes use more that. So again, when you are an application developer, you may be not just limited to one cloud, right? You use the interface of another cloud, you go where the costs are. It's a very lively business. And you could say also when maybe you have lots of storage maybe right now in Amazon S3, but you have a good deal maybe with a company here in Iceland, like Borealis or so, and you get a good deal, then you maybe rather port to this. Of course, we have the transfer costs as we discussed, so you have to make a point. But if you see examples in the cloud, you see often these people hopping a little bit, right? You will suddenly see Spotify is there very big, suddenly Spotify is there, but IKEA is here and IKEA is there. Usually because over time they switch. Of course, they have big costs, right, as big companies. So they also will basically look at this every now and then. Is it still good to do it on this cloud provider, or don't we get a better deal by switching? So hence, it's a lively business. And I mean, if you go downstairs, you just came new in class. If you want, after the class, you can go downstairs and talk to the people. If someone, tells you you should be not there, you say, my student, University of Iceland, and roam around. So I really invite you to go there. You see, it's a very lively visit alone in Iceland, right? And now think about the world. That's, of course, another issue, especially with the hyperscalers. And also today, we discussed it actually downstairs, also in the opening. Basically, everybody from us use heavily cloud computing without knowing, right? All your apps are basically fueled by cloud computing. Who has a smartphone? Or should I ask who has not a smartphone? Right? And of course, these are factors you have to see. So the usage is increasing, and here and there you see really lots of interesting business models. And so I encourage you in a way. I cannot teach this all the time because it's not my work here as a university professor to go through all the usage examples that Google has, for instance, on their site. But you see that basically when you go to Google a little bit on these Spotify, Google Cloud example, they really do a very good job. What I also want to encourage with this slide, not only doing good marketing, but also kind to, I would say, hook in a friendly word, right? So meaning you see here, get started for free. New customers get $300 in free credits. Of course, people want to get you to this cloud, use it. And once you're in, chances are that you not switch so easily, right? So in this sense, you find this all over the place. You will see when you go to Google Cloud, MS Azure does the same way. Google Cloud is just really perfect in this in a way, but also you will see it when you do your assignment in SageMaker. You have the SageMaker Lab, no credit card, but always there comes a blink, hey, for free. If you now enroll to AWS SageMaker, where you have to use a credit card, you get $30 for free, $50 for free, etc. Always are these hidden treasures where they try to really get your credit card, and this is something what you should have in your mind. And of course, it's business, right? So it's, of course, the idea to have you inside this cloud and hopefully never leaving. From the look and feel from the Google Cloud, you see here some examples of the computing. Just to connect again what we had in Amazon, you have basically VM instances in the compute engine. So you see all the infrastructure as a service aspect we discussed. Storage is there also, bare metal solutions that you can have. And of course, the pricing models depends here on the TPU versus 2. You have different categories where basically you have your accelerator running from the regions. You remember that's the same we did in Amazon, right? With East Ohio, you see basically they're very similar ideas. Of course, it's not one-to-one mapping in a way, but still, if you look behind the ideas, definitely you see analogies between all the different cloud providers. What cloud in Google has, it's a specialist processing unit. But these days, it's not so special anymore because the cutting-edge NVIDIA GPUs are already having Tensor cores, which are actually also optimized for deep learning and machine learning, as we discussed. Hence, the Google platform is also another very strong candidate for you if you develop applications. And that's why I pick it in this PAAS module, because I think the whole development cycle, how to build and how to scale, is essentially quite nice in Google Cloud. But AWS would have very dedicated service like SageMaker, very nice for machine learning, deep learning, very special. Google Cloud is good in getting the things together in a development cycle, right? You could do the same in Amazon a bit, but I think here it's really nicely reflected with the Google App Engine that you, for instance, can use, and that, you know, Philips, Angry Birds, and others have used in the past, are using partly here and there. So this is something quite interesting. Again, by using the Google Cloud underneath with IAAS, you're scalable, which helps you to scale up and down. But then there's lots of admin console work where you basically, as a developer, can use lots of these, you know, Lego bricks to monitor your infrastructure, but also then to develop, which you see here, is now the idea basically of combining all of these building blocks to build your own application. Of course, the core of your application, we discussed this upload, download service here of the images from Iceland, right? Pictures, videos you do. This is something what the core logic still you have to do. But the upload module, right? How you do this, or the credit card swipe to basically get the images down and to download, all of that is existing. You just have to put it together. And this, of course, means lots of development work, less maintenance done by Google. Of course, you have to pay for it, but still it can significantly increase your cycle. If you think about, usually you would have to develop all of that on your own as a Java development, right? And there are other courses that also show you how that works in Java. I think Matthias has some interesting courses, how to develop apps and so on without the cloud, more in Java and things like that. So this is something where you see here are different Lego bricks that you can really use nicely. And of course, the region is a little bit what you already also know. You have to pick a little bit where you basically want to have your customer base. But essentially, the same story goes as we had in Amazon and other. The location can be important, but it's maybe not the best, or it's not the big killing factor necessarily. So from the App Engine perspective, you can imagine this is basically something which already is for a specific purpose, how to create an app. Basically building on this fully managed platform, having basically rollouts of your software. You have your development cycle supported. You have different versions that you can track. And of course, the highlight for the cloud for us, I mean, is the scalability of users, right? You don't have to think about where you deploy this on a server, on a web server or something, and then suddenly you have 10,000 requests because your game is very popular suddenly. Social media, one influencer could maybe mean thousands of users, right now. So, and your web server will simply break directly because it's not able to cope with so many queries, or your application logic in the back could not cope with so many queries. So here you have really the scalability again as one of the main selling propositions. And many of these things are also a bit cost-free. It's not that you have to pay for every little bit you basically do with the App Engine and so forth. So an example of this is basically shown here from different vendors. Again, it's not my job to go in all of these different use cases, but they are basically having all in common to have a little bit this uncertainty. They basically need lots of data, so there may be pictures and so on. You see a little bit also the benefits if you use this particular one. Cut annual IT overhead by up to $500,000, right? So you see really the IT overhead in here developing, in basically having administrators on that. Rather, you can focus on your core business. Scales to more than 30 terabyte without performance issues, right? So there's also something which for a normal server, if you do that on your own in a cellar, you really have to pull out a lot of strings already to make that scalable that way. So hence using the cloud much more easier. So, and again, when you think about that, all of this, bring it in the App Store and all of these tracking of versions, maintenance, right? With the game comes also maintenance, the cycles is really nice supported. And with compute, you have, of course, different areas how you can really either, step by step increase the costs. And when you do this, of course, make sure also to put that to your customer, right? So when they basically pay for your app, indirectly, the payment should be also paying your infrastructure you use underneath in your business model when you do an app, right? This is also important. Don't think that you can just do a €1 app and then suddenly you realize, well, I need much more cost for the infrastructure to actually realize the service. And you can go on and go on. I mean, this looks like a selling proposition here, but it's really nice to combine this with all the Google, you know, interesting components like the searches they have. Obviously, Google has a good track record in searches. So there are many components around this, how we can search. SQL we'll talk about. All of these are basically quite nicely there, including security checks, monitoring of your application. It's really running well, testing, and so on. So if you are want to develop an app, that would be probably one of the good things to start from. And when you think about the web application, again, from an example point of view, you see here how this Lego principle now works, right? You basically have idea that users use essentially this kind of app engine, some cloud storage is clear. And then basically you have lots of these different aspects that you can integrate. Here you have some memcache, a very specific database that you basically can have in the Google Cloud. Task queues, which means what is your app is doing, could be loading new level data for your game, could be, you know, basically different aspects. And all of these are existing. You don't have to develop them. You just have to integrate them basically using the app engine in your application and can just maybe actually use these services partly even for free. Then you have here processing, monitoring, publish, subscribe, so notification paradigms, data flow, Google BigQuery. These are all strong components doing a very certain thing, like a Lego block is doing, right? For one specific purpose. And then you basically can, with a couple of, you know, points you pull together, have a very strong application that scales, and basically the development cost is at a fraction that you would have otherwise. Including, of course, a lifetime, which is important and not to be underestimated. The cloud logging, monitoring is also important. Just as an example, scalable movie backends for games is another example where you have maybe a game app and a game server using, again, this memcache, specific data store, and different data stores for different elements. So, of course, we will talk a little bit about now you maybe want to combine SQL and NoSQL data stores. It doesn't mean that you have to always use one. All have their benefits, right? SQL as well as NoSQL in order to do this. And you see, it's the same components we talked before, memcache, PubSub, data flow, the Google BigQueries, and so on, but for a complete different application. And that's the Lego principle, right? You can do this and build your Lego house in different ways, but still it uses the same blocks. And that's exactly another idea what you see here. Again, I think very important for the development of these apps is also the cycle, because if you don't have error reporting and this cloud logging, chances are your app has a big bug and then suddenly the user base will shrink and then you're off the market very quickly. Or, you know, the ratings say everything today on an app. In this sense, this is also not to be underestimated, that the whole development process in terms of monitoring and so on and updating is also supported. Now, of course, coming to costs. When I talk about cloud, we have to talk about costs, unfortunately. But you see that some of them are actually affordable, some not. You see the search API, you can imagine for Google searches, very smart. You already buy here $2 per gigabyte, it's still okay maybe. But for some aspects, it's even free. Outgoing traffic, you see again, strangely always costs a little bit, while incoming traffic is free. Again, the idea of accumulating the data, once the data is in the cloud provider, you basically should not go out with the data, keep the data in the cloud so that they don't lose money, right? So basically, this is a vendor lock I'm basically always alluding to. So they support this significantly. And yeah, instances, you know already from the compute hours. Of course, these numbers change every now and then. It depends also where you go on the location, as you know, from the Amazon in infrastructure. And of course, again, the idea is not thinking always just about $2 per gigabyte. Your game will use that heavily, maybe. And then you basically, the accumulated costs can quickly go high, right? Still, you always have to put it in context to, you know, normally you have to have your own server created, you have to update it, you have to maintain it, OS, security updates, Lots of maintenance goes into that. For the virtualized infrastructure, then even comes on top your app development and stuff like this. So this is something to think about. So let's talk about NoSQL. Who has used NoSQL data stores? I think I'm asking about that already. NoSQL a little bit. So key value stores. So we look into this a little bit. Who has used SQL databases like Oracle? Structured query language should be basically, I hope, in almost all studies lines these days. Yeah, okay, we have a fan here. And there's a big debate, actually, a big fights between SQL and NoSQL databases. But the interesting thing is basically you think about a NoSQL concept when you have very, let's say, unstructured data. You would have not this typical name for everyone, sure name from everyone, phone numbers from everyone. So here we're basically talking about what you have basically, it's a good example in Facebook. Some give their complete names, some not. Some give telephone numbers, some not. Some give their websites, some not. So basically every entry basically would have different information. If you do this large scale, let's say you have 100 fields, right? For this, it doesn't make sense anymore to have a structured query language database because you have lots of empty basically values there, right? So there the idea of NoSQL is the simple object key value, something you already know from MapReduce, right? Basically having a key and then a value, you can just have name, this, sure name, this, phone number for this user, and for the others you have complete different information. Still, the key works quite fast. However, if you think about SQL databases, you still have the strong indexes, right? You remember, when you have an index on an SQL database, it's basically unbeatable for what you have in terms of when all have the same, let's say, information, like the phone number, which might be in your app very important as a contact manager also. Then with one click, you directly want to have this information. So there's a back and forth, and as I said, it's not really thinking that you should always use in NoSQL databases. That's very important as well. So further, some business models on this, Philips, and as I said, also basically we should, in former lectures I had some longer NoSQL stores things, but basically we need a complete lecture on this to do this properly and have all these different versions of this NoSQL data stores put in. So one example how to use this is basically the business case here on Philips. You know, basically this Lightning app, essentially, where also there is basically the idea of just using everything which a Google Cloud provides. You have your app and it's based on this Google App Engine, right? So you have here a Google Cloud platform, which you use with some NoSQL based Google Cloud data store, because every user will have not the same rooms, will have not the same locations, will have not the same settings of the colors. So there the information is very different from each other. So basically that makes sense, for instance, to use this just as one example. And the other one is, of course, scalability. You know, basically when Philips rolled that out, doing this, they didn't know that it would be such a high success. It was kind of a risky business for Philips at that time. They did lots of light bulbs, but if this Philips Hue is really taking off, you don't know. And of course, now we know it's very, very popular. Who has something at home from this Lightning Philips Hue? Especially in Iceland, it should be quite popular, because there you basically have, you know, the operational cost would be quite low. But this is something which very nicely scales up, scales down, but you see here also nicely in the elements that they taught about the backend. They choose actually the Google Cloud platform because it scales instantly. Because you never know how much they basically put in their rooms, how many of the lightnings, how much you have to basically steer and control, how often it is used, how many users. So all of this is kind of unknown, right? It's just standing in the shop and let's see. And this could be regional. And basically this is something where the cloud can be quickly going up and down with the needs. And of course, the scalability is one of the key elements. That's why I touched this again and again and again. So coming back to this NoSQL based cloud data store, what is it? Basically a very flexible data structure, as we already talked about. When you have something not directly how we have in an SQL database, still the interface is similar like SQL would do. And basically you have not the strict schema. If some of you know, the database has always a strict schema. You have to fill this field, you have to do this, you have to do this, constraints. And of course, they're usually also not that powerful of having triggers or stored procedures in the database. If some of you may still know, there's also application logic you can put in. But they're usually very popular for everything which is really flexible. As we discussed, lamp moved from A to B. Suddenly the room is basically not anymore the room that it was before. So you need a very flexible update structure where these basically are very good in when it comes to basically read a lot. And read a lot from this data is something where they also want to, of course, scale up with a request. So it should be very quick. And there are different databases on this. So you see Cloud BigTable is now a column database. We have a document database optimized for documents. You see also even in the NoSQL space, that's why I said we probably need a whole basically course on NoSQL stores, usually in a university or so. You basically have different versions how that would work for different types of data. And there are different implementations also. Hence, you see here the key example, which essentially reflects the idea of what we already discussed a little bit. So if you have one key, of course, it identifies still a person. Some give their email, some their first name, some their location, some not. You see the values vary a lot, and which are largely called just bins, essentially. And then you fill that with the data you have. And there you are very flexible without any schema. And without, of course, this is clear that this is, of course, enough very, very fast. And these are just a couple of components. You see also a typical PostgreSQL, MySQL, you can also adapt to it. That then you are again in the structured query language, schemas, a very strict database design. And the beauty is really to combine these, as I said, as Lego blocks before for the application in question. Right, some general characteristica is basically that these are also more and more used. This is basically here some of the story highlights again, where you basically have interesting insights that you can basically look into this. You can basically have data graphs easily built on it. There are different, let's say, Lego bricks that makes it happen. But of course, the key selling proposition of this Cloud BigTable is essentially that you really can have petabytes of data, right? And this is not really an SQL approach, it's a string-based approach we have seen already, so NoSQL. But there are many, many people using the Google Cloud for this BigTable reason. And you can even connect this with the Google file system, parallel distributed file system, something we cover a little bit more in the HBase course, but it's also enormously important to get this across a different, let's say, servers. You can imagine with petabytes of data, the access to this needs to be also a bit distributed. If you have then a table on top, which you have to do basically in this distributed system, it gets complicated when you want to do this your own, but that's where basically then the Cloud BigTable has its selling proposition. And you see here how that is again putting in the Lego brick box, a couple of them out. Similar ones we have already seen, publish and subscribe mechanism. Here we're looking into a finance application where you just combine then from the time series in the finance that you have basically several building blocks like the data flow service. You have a storage in different types of ways where you then basically have for different purposes, again, these combined, and then do machine learning on different platforms. Dataproc is something you already basically know from AWS and MS Azure. That's also the whole world of Spark, Hadoop, MapReduce. AI platform is a very specific service for machine learning. And yeah, Data Lab is another one which have lots of statistics and so on. And with this, you basically have all the ingredients again for a very nice finance application. You can do quickly roll out. And again, what I don't show here on this one now is, of course, you have the whole monitoring, logging, updating, versioning, all of that also included. So then just another BigTable example would be the PageRank we had already before. You think basically the idea of using this kind of key value store is the same way you can basically have here the HTML web pages. And then the opposite way you would basically have the anchors of the web pages. And then with this, you have a very nice way how to look up web pages. And from there, create then basically the idea that we had already with the graph. And yeah, just to compare maybe before we close the first part here is a little bit the SQL databases. As I said several times, structured data, then you better stay with SQL and indices and do a good schema there. especially if you need data definitively, right? Then, I mean, SQL databases are beautiful. NoSQL data stores, as we discussed, is rather for this, which is really unstructured, it's much more easier to deploy, and it enables much easier geographically distributed elements. Of course, here you go with the problem that sometimes the data has low data consistency, so you just don't have a name sometimes, just an email, but that is maybe not killing your application necessarily. And yeah, lecture 14 will talk a little bit more about this at the end of the course, going and then in these different versions. Here today, it was just to show you a little bit that this is one of the PAAS big sailing propositions, that all of these are already deployed in different purposes. And you see, if you want to do it your own, there are lots of open source tools already there that are also key value stores and NoSQLs. And you basically can then implement, for instance, here in HBase, the idea with the websites of having then the row key and then to really search easily between basically all these different websites is, of course, something where you can nicely map this model, especially because the URI is a very nice way how you structure information. MongoDB is one which is also there more based on JSON. So you would define this essentially in another way, the schemas and so on, but works pretty similar. Also key value store, Cassandra, and you see there are no big yellow blocks, so I don't want to have from you the difference between Cassandra and Mongo or something in the exams, just that you know there are different of these implemented that you can use for implementations. And yeah, you can basically go on and go on. I go a bit quicker here. Maybe a short summary of the Google App Engine. It's really just 1 minute, and then we break.
Give me 1 minute and I'll show you how App Engine can help you ship your next great app idea. App Engine is a fully managed serverless application platform with simple administration. Write your code in any of the supported languages, or run custom containers with the language and framework of your choice. When your code is ready, run gcloud app deploy. App Engine handles the work of uploading your code and running it on Google Cloud. It seamlessly scales from 0 to millions of requests as your app becomes popular, and you only pay for what you use. You can easily host different versions of your app and split traffic between them for A/B testing and incremental feature rollouts. You can debug and monitor your app, even in production. And for the security of your app, App Engine offers free managed SSL certificates on your custom domain. App Engine works as a great backend for mobile apps, APIs, websites, and more. So next time you've got a cool app you want to ship quickly, take a minute to look at App Engine. To learn more, check out cloud.google.com/App Engine.
All right. Of course, I'm not paid by Google, just that you know, but they have sometimes really good PAAS development blocks. I hope you know the story, and we break here for a couple of minutes before we go to the second part.